Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you've joined us. Our topic today is best practices to secure containerized apps with next generation application firewall, web application firewall. Today's webinar is sponsored by Signal Sciences. My name is Mitch Ashley, and I'll serve as your host and moderator. A few housekeeping items we want to take care of before we get started here. One is we're recording the webinar, and we will send an email to all participants that includes a link to the webinar recording as well as the slides from today's webinar. We're also giving away 3 Amazon gift cards at the end, so please stick around all the way to the end and find out if you're one of our lucky winners. We also want to encourage you to ask questions, and our speaker today loves questions. He's happy to entertain questions even while he's speaking, not just at the end. So toss those into the questions tab on the GoToWebinar software, and we'll be glad to get to those as soon as we can. So let's move on to our topic, best practices to secure containerized apps with next generation web application firewalls. It's my great pleasure to introduce today's fabulous speaker, Doug Coburn. Doug is Director of Professional Services with Signal Sciences. Well, let's jump right to it. Doug, why don't you take it away?
Sure. Although I had some technical difficulties with the GoToMeeting when I joined, it actually crashed. So go ahead and start that sharing again. I think my audio is back.
Hey, you're back.
Cool.
And we see your screen. You're good to go.
Perfect. Oh, making it exciting first thing in the morning, but it's great to be here. Thank you for having me. I definitely appreciate it. And I'm going to be talking a little bit about securing containerized applications, primarily talking about the kind of traffic and securing it from that side, because that's the side I have a lot of experience with. And that's kind of my background also, talking about microservices. So let's go ahead and talk about how do we kind of get to where we did with microservices. So prior to Signal Sciences, I actually worked at a company called RNIO doing functions as a service. And it was, for me, very interesting to get into the microservice sector, going from regular servers and VMs. So what we had started with historically was the traditional servers approach. You had physical hardware in a data center that you created, a colo, something like that. And everything was very monolithic. You would have one, maybe a couple servers, if we're talking about a small application and not high availability, which might be a web server, a SQL server, and some other kind of back-end components. So this was a very monolithic approach. You also had a waterfall type development. So you might have maintenance releases every quarter and major releases once a year. And everything was very kind of consistent in this approach across the board. You then started to move towards VMs and separating out functions more into different servers. That's led us to kind of the n-tiered architecture as opposed to primarily having 1 or 2 boxes. And that's the kind of system separation that we see here. We start to see a more devolving of roles to different types of servers and different locations. And that started to lead us to what we now have with containers. So I'd hope at this point everybody is familiar with containers to an extent. And containers was very interesting to see people moving from the traditional VM or server-based approach. Generally, it was a very slow process to move from a monolithic approach and just dropping a whole thing into a container, and then eventually slowly breaking out functions into actual proper microservices where you have a pared down server or something like that in front, and then all of the functionality is now being distributed across different containers. One of the advantages of this approach is it helps doing things like DevOps, and also what people are talking about now, DevSecOps, with the different types of agile mechanisms where one microservice failing doesn't necessarily cause your whole server to fail. The historical monolithic approach, one thing failed or you had to update one thing and that caused a problem and potentially everything went down. Kind of on the container microservices side, the goal is, hey, I can have a whole bunch of containers running. We have one execution that failed, that's fine. It's either going to self-heal, it's going to only be part of the pipeline. Maybe it's just PDF creation that fails, or maybe it's just access to one section of your actual application that fails, but overall the main part of the application remains healthy. This gives you a lot better kind of resiliency in your application, along with being able to scale and a lot more density in your server usage, as you're able to use up more resources by using smaller slices that are very targeted for the tasks that you're actually doing. And one of the things here is, as you're deconstructing an existing monolithic application, you have to start thinking about things that you didn't necessarily think about before. One of the things is, how do the functions communicate with each other? So historically, it was all within the same application. This would mean that you didn't really have to worry about as many layers of authentication or communication. It's just natively inside of the same app. So we don't need to worry, it's fine. You might have to worry about access to the database, but you don't need to worry about a particular function within that code because it's just part of the overall application. But now, as you move into this microservice approach and you're stripping out functions from a web server and putting them into various microservices, you need that communication layer. So one of the common forms are, maybe they talk via REST or SOAP. Nowadays, also potentially HTTP2 with gRPC. And there's a whole bunch of different mechanisms how the microservices can communicate with each other. But the majority tend to be an HTTP-based communication between the actual services in a deployment. So as mentioned, this leads to new security concerns. You have to know who's allowed to use the function. Is it all services? Does it have to authenticate in some way? Is there a token that is service specific? Does it reach out to another service that's an authentication service that tells it what role a user has and what they're allowed to do? Are there sanity checks? Because now you're taking a function that might have just been passed something internally in an application and we're fine from that perspective, and potentially having data that's actually being generated from outside of your application. A common thing that you might think about, whether it's a service in Kubernetes or say a Lambda function, is you have a payload that's being passed. And where does that payload generate from? If it's something that somebody is hitting in a forum and hitting submit, well, that leads to a mechanism for attackers to be able to come in and do malicious things that can make it all the way to that particular function. And if it's not secured and locked down and sanitized in a good way, could lead to compromises. And what about the environment that the function actually runs in? How is that secured? So is the actual container done with best security policies? Are you using things like Aqua or Twistlog to confirm that you've set things up correctly? Does the container allow the process to run as privileged, or is it running as a different user? There's a lot of different things that you're thinking about just from the container configuration, along with the actual potential communication layer. But it does give you, though, along with this new security concerns, is being able to separate kind of your process for doing updates. Again, you're moving away from the traditional web-based, or sorry, the traditional waterfall-based updates and being able to do it on individual functions. This means that dev teams can have potentially their own release cycles per microservice as opposed to the overall application. And that again drives things like the DevOps model that we see nowadays. Also, it's easier for somebody coming on board to look at a smaller code set for a particular microservice and understand what that function is actually doing and get up to speed and be able to do things. They might not have as broad of a view because they might not understand everything about the product, but the areas that they're working on tend to be a little bit easier to focus on. And again, app owners can focus on particular areas as potentially the whole product, although from my experience, it's always great to have a broad vision of how the overall application works. So this was an interesting article that I had found in the past, and I liked this quote because it's talking about an insecure API service. And the model, and this is going to lead into the next thing that I'm going to want to talk about, is that in a lot of these environments, whether you talk about Kubernetes or Docker Compose or any of these systems where you're using microservices, once you're in that container, you're effectively trusted. And if those get compromised, you now are potentially compromising more than just that individual container, as people are able to start exploring the environment that's actually around them. So this is something that you definitely want to look into, and it's something you want to be able to be sure that you're securing, because one of your biggest interfaces into any environment is actually your web front end, because this kind of gets you in the door if it's not secured. So let's talk about EastWest Traffic. One of these articles is actually on a product page for Cisco that I found interesting, is with the way that applications have moved to this distributed model across microservices. Now, 70–80% of the traffic is east-west. So in traditional models, a lot of the traffic that you were worried about was actually going to be from north-south, meaning from outside of your environment into your environment and then back the other direction. With the shift to the container-based approach and the hybrid model with extremely distributed applications, you're starting to see a lot of the traffic be internal communication between these actual services, like we're talking about here in the container world. And what you potentially don't monitor, because it's historically been a trusted network, is what's actually going on in between them. As long as nothing malicious is going on, that's fine. But that trusted model of, are they behind my perimeter? Are they outside the network, or are they inside the network? It's kind of disappearing, because now you have to think about, well, I have all these other mechanisms of communication. If I get something compromised in there, does this compromise my whole environment and the east-west type traffic and not just the north-south traffic? So if I have one malicious container because it's compromised, what does that actually say that I am vulnerable to from across the whole kind of internal network? Okay. So one of the things that is very interesting in these types of models is the protection and potentially the ingress. So historically, the ingress has always been your actual network layer, your F5s, your Impervas, your Cisco routers, and other devices at the actual data center ingress or your network ingress. And that worked when that was kind of your main point in, but now we start having other types of mechanisms. So in the Kubernetes, OpenShift type of world, you start having things like ingress controllers, which might still be something physical, but often is software-based approaches, whether that's Envoy, whether that's Nginx, Envoy Proxy, Traffic, and other types of ingress controllers out there. There's some good pros there. Being able to be at the ingress controller into your clusters gives you a little bit more of the traditional model of, hey, let's inspect stuff north-south before it gets into the containers, as opposed to waiting and trying to protect at the application layer. This is often desirable to a lot of companies from a development perspective, because it tends to be a lot more transparent to the actual app teams and the microservices. It's before it ever reaches there, and means they don't really have to worry about it. They can just do their code and cool, you're done. It tends to be a lot easier, especially in large organizations. My experience is getting individual app teams to enable a new product, especially a product that they didn't bring in, can be a challenging discussion to have in a business sense, and getting the buy-in in order to get the development time and cycles to actually add in a new product. Additionally, and this is something I talk about in not just the containers specifically, but also functions as a service, is you really want to stop things before it hits the application or microservice. If it doesn't hit the application or microservice, that's potentially less time processing something that's malicious and not actually of value, so that you're using less compute resources and can focus on actually just running and doing the stuff you should be and protected before it ever hits the application. Some of the cons are if the container is compromised, then it's harder to track the traffic that is in the actual east-west. If you're at the Ingress controller, it's similar to a traditional model. Once the perimeter is breached, you have to know how things are going within that actual network. So if you're only looking at the Ingress layer, well, you're not going to know about what's going on kind of in the internal network behind the Ingress. And it's also harder to break out information on a specific microservice because a lot of the communication is now going to be HTTP based. You can see some things based on paths and domains, but once you start having the Ingress controller, it's not even domains, it's generally paths. Like, oh, hey, if it's /Apache, go to this server. It's /Nginx, go to that server. You'd probably use something a little bit less names of web servers, but the things behind it could be any type of servers, and it doesn't really matter what the domain is because you can have everything off of one domain. The other is also at the Ingress controller is when you're setting up detection and protection at the Ingress, you tend to have to enable this for all microservices behind the Ingress and not just the individual applications that you're ready to onboard. So for some organizations, this could be an issue because they might want to do it one application at a time. You might end up having to set up different namespaces with multiple Ingress controllers if you want to break things out and have something protected on one and not the other. And it can lead to a lot of complexity from that side of things. So Envoy is and Istio are Envoy is a common Ingress controller, and with Istio doing things in a server mesh fashion, kind of gives you the best of both worlds. So you have information going on and being able to do a lot of detection and service discovery at the application and pod layer using the Istio as it's distributed across, along with having the Ingress controllers with the Envoy. And from a protection perspective, this allows you to be able to plug in. So for example, with Signal Sciences, we're able to plug in with Envoy or Istio. And this means that you can actually see what's happening, not just what's coming in from your customers, from your browsers, from your mobile apps, those types of things, but also you can see information about traffic that's internally in your actual east-west type traffic. This method is still very nice because it's still pretty transparent to the app teams. They can focus on their actual application, and the Istio portion of things will be doing a lot of the service mapping and be a proxy for the application. So it still sits in front, and the pod is sidecarred into there, and it just makes, again, things very transparent and easy to use. So that means that instead of having to set up something custom in their actual app, they can just rely on this layer that's kind of sitting above them without them having to worry about doing anything. So it's a nice kind of model that gives you, I think, a lot of flexibility from what I've seen, and it doesn't have to be Envoy. Generally, Envoy and Istio is kind of the most common approach that's out there. I know there's some others, but it is possible to tie things into, say, Nginx or to Envoy Proxy or Traffic or some of the other common Ingress controllers. So there's a lot of flexibility in doing this model. And again, it makes it a lot easier for people to buy into it if they're not actually having to do things. So coming back to talking about a compromised web application, and you become trusted, as mentioned. If you can get into one container, that's command execution, which is a common one, or code injection, which would be another one, then you have a lot more information available because there's services that you expect to have access to as a container within that cluster. It's similar to even EC2 instances. There's the IP in the past that Amazon has for getting information about the instances. And it used to have a lot more information, but they had to restrict that based on vulnerabilities that were found to cause command execution and actually get data back about your EC2 environment. Similar types of APIs are available from the Kubernetes side, whereas when you're running as a trusted service, you have a higher level of access potentially, or a different level of access as trying to just get into the Kubernetes cluster directly. And I included a couple of links here to some articles I had read that I found very interesting in the past. So another reason why this is important is a pipeline. So one of the new approaches to doing deployments is kind of this pipeline approach. And what this means is you have code-driven updates happening automatically. I have an example skim server that I wrote here in the past. And we can see here that at the top, I have a folder called Circle CI. So that's one of the CI/CD tools that you can use nowadays with GitHub Actions, and there's a lot of other tools out there. You don't necessarily have to use Circle CI. You can use other ones, whatever you want to use. The kind of moral is with a pipeline, you have a lot of automation, which is good, but also potentially a little bit scary. So in this case, what we have here for Circle CI is pretty straightforward YAML configuration, where I can have a container that in this case was Python 3.5. I'm going through configuring that container, but I also have things that I'm testing for as I go through each step of the way. So each step allows me to be able to set up the container, but also be able to do checks to see, oh, did something succeed or not in each of my levels in order to determine, did I have a successful build or not? This happens every time I push out a change to my GitHub repository. So when I push to my master branch, because that's what I'm monitoring, I'll automatically trigger a build that can happen in Circle CI that could actually also deploy if I wanted to do things completely automated fashion. So what we have here is an example of me actually running a build. And in my example, I did something that maybe you wouldn't do in production. Maybe you would have some kind of approval process. Might actually be in a Jenkins server if you're running your own kind of CI/CD pipeline instead of using something like Circle CI. But effectively, I can kick off a change to my GitHub repository, and this will go all the way through, build out the new container, and if it's successful, it would actually deploy it automatically to my Kubernetes environment. So what we can see here is based on that actual last run, in this case, when I did it, we can see each of these versions here. I was testing a bunch of updates at the time, and we can see that every time I actually made a change to my master branch, it was actually kicking off and pushing out this new container. Now, on the Kubernetes side of things, there's a few ways I can do it. In this case, what it was doing was it was actually updating the deployment within Kubernetes with the new image version. And so what we could see here is that the version of the image was automatically updated and deployed. Again, whether you want to do that in a production environment is a whole nother question, but it is definitely something that I have seen, and it's very easy to set up an automated pipeline like this. I can get it all the way from hitting commit in GitHub to having it pushed out and going to production. You might have environments where you have a temporary production and you back off the other one so you can fail over if you detect something, but potentially it can be a very quick process to get something out from committing a code change. Hopefully, generally people will be doing things on branches in GitHub, but I have seen times where people mean to push to a branch and accidentally push to master, and that can lead to things getting out very quickly in an automated process like this. So the container security focus. This is just something that I talk about if you haven't noticed throughout the actual presentation so far, is the app is part of the container. Yet in a lot of organizations and a lot of products out there, I see that it seems to not be very important or almost ignored in the container strategy. I see a lot of talk about how I secure the operating system for the container. As mentioned, is it running privilege? Is it running as root or non-root? Where am I getting the source from for the image? and a lot of things along those lines. But what I don't see a lot of things talking about is how do I secure the actual web applications, because anything that's using HTTP to communicate now effectively has elements of a web application. I might call it just your API and what is my API security strategy, but at the end of the day, it's a web server that's listening and running HTTP traffic, but how do I actually secure that? So a lot of the historical things come back into play for web servers in general. How do I secure it? How do I sanitize? How do I make sure that any inputs, in this case, the inputs might be JSON elements when you're doing a post as opposed to a form element, but how do I make sure that those things aren't going to lead to vulnerabilities within my container? So the speed is scary from a security perspective. You now have things being released very quickly and not necessarily with the same eye to security that you might have had in a traditional waterfall approach. You want to get things out fast to have new features and deploy quick, fail quick, and fix quick type thing. So it's good from that perspective because it allows you to get a lot of new things out very quickly. But you start having to think about things in a different fashion. The traditional model of having just a central security team make all the security decisions is very hard in this model, especially as you scale into large organizations. The eye to security needs to be not just with the security team, but also a thought process that's happening from the time of development and up. As mentioned before, a silly mistake can go out very quickly and potentially compromise your infrastructure very easily if it's actually found. And from a containers perspective, it makes it a lot easier to go from development to prod. You have a whole operating system, everything's contained, and you're duplicating that once you're ready to move to prod. And it becomes really just a click of a button of, hey, yeah, we're happy with where things are on this dev instance. I'm now going to update my deployment in production. And now we're on the new thing, and theoretically, it's exactly the same as dev because it's the exact same container. It's just has some different environment variables to make it into a prod instance for whatever it might be. Might be as simple as just setting a flag from dev to prod. Could be you have to put in some different keys, but all in all, the only difference is usually is environment variables. What I do see often is a reliance on third-party images for the containers. So from the containers perspective, you see a lot of containers being used, and you would generally expect them to be secure if they're from Debian, if they're from other trusted vendors, and they usually are checked out and probably would be. But I do see in a lot of companies, even for those ones, a desire for them to be cached and hosted in their own repositories and verified that they are actually secure and nothing malicious has managed to get into those containers. If you're going straight from the source, especially from smaller unknown sources, there's always a risk that has something malicious been included that could be bypassed and again, compromising my environment. So we're not talking about just, okay, here's a web app and how do I get into it? We're also talking about how am I creating and deploying these images and securing it before it even gets deployed and running in your environment. It does lead to the easy to build, easy to push model. Again, because you're focusing on microservices, it tends to be a lot quicker of a development cycle for an individual microservice. So it's easy to build, test, fail, and keep testing, and then get to a happy medium, and then push it out when you're ready. Then from an orchestration perspective, Kubernetes has done pretty well in this environment, and I think is, for the most part, won that kind of container orchestration war. Generally, most products you're seeing out there now, like Amazon Fargate or the Azure functions or the Google functions, and most of the things now behind it are using Kubernetes, or you can use a hosted Kubernetes, you can use an on-premise or a hybrid, but there's a lot of areas where you're using Kubernetes, which is really great because from a scaling perspective, it allows you to be able to scale out very quickly, especially with the cloud environments. It also makes, as mentioned earlier, automation from a CI/CD pipeline a lot easier. Since everything's API driven, it's easy to call those APIs from your CI/CD pipeline and actually do deployments and updates. And it's also the quick to scale out and push out a bad push. So, and I actually have seen this happen in real life. Somebody accidentally commits to the wrong branch of GitHub, and the automation was from all the way through. A bad push went out, website was broken for a period of time until that could be reverted, and then a new release was pushed out in order to bring it back to the working version. So it's a great thing from a scale and speed perspective. It's still scary from a security perspective to ensure that you actually are securing not just the container, but any of the applications that are running inside of the container. So an exaggerated example that I've done from Python is in my Skim server, and you can see it there. It's usually commented out unless I'm actually running it, just to show how simple it is I set up a simple route in my Flask application that says, I'm going to get information from the actual argument called query. And rather than sanitizing that, making sure that it's not something malicious, I'm actually just running that directly. And you can see the result that I'm actually doing a system call based on whatever was in that query. Now, hopefully, nobody is actually doing this in real life. But again, I actually have seen similar types of instances like this, usually especially for things like SQL injection, where somebody's like, oh, I'm just going to have a query endpoint and I'll get it from there directly because it's a trusted endpoint. And as I move to microservices, there might be now a potential exposure where you can actually get to the endpoint directly and bypass some of the authentication and then run a SQL command. And voila, you now have a SQL injection because of the way things were coded. So in this example here, I added in that route. And what I did was had my CI/CD pipeline that I had already showed screenshots for. And I went through and actually ran it. Now, what you can see up in the URL is that I had my silly endpoint with a query where I was doing a command execution to get information. Now, to get the data out, what I was doing, if I could actually get to the etc password, in this case, because it was a container, it wasn't there. I was actually hitting a webhook website where any data that was found, and I could do different files, was actually ending up in this webhook where I could actually see the data externally outside of my environment. Now, the containers might be configured to not have the ability to go back out, but they also might be. I've seen it be both ways. So there's always that possibility, along with, again, being able to case internally. Like I might actually, instead of doing etc password, I might have done a curl, if that was one of the utilities in there, against one of the services APIs for Kubernetes to see what I have access to as a trusted service. So again, over the top example, but it highlights something that needs to be thought about and why web applications should be thought about from a security perspective. They're still vulnerable even if the actual container image is secured. So it's all great to have your container process creation and scanning done, but it doesn't help if the web application itself is still vulnerable within there. When I talk about web application, we can talk about it as a full stack web application that's serving up web pages, or just a API that's doing things over HTTP or HTTP2 and accepting those types of requests, because that's the biggest mechanism into the environment. And again, compromising that web applications can still allow that access from an east-west perspective. Generally, it is going to be from an information gathering and trying to get data, but it does raise that concern of what do I do to actually secure my east-west traffic to make sure I'm not getting something that's vulnerable in the cluster, compromising the whole cluster, because that's the last thing that we want, because what else are you running? There's obviously ways you can mitigate that risk with namespaces and having things be kind of locked down in that way. But at the end of the day, there's still a lot of potential information that's available. So some of the areas of where to implement that security can be at the application layer. That's one mechanism. It's probably the more traditional method where you're actually doing a protection in the actual application itself. You could do it as a separate layer. And so that could be in a few different ways. That could be as part of an Istio service mesh. It could be as part as a separate service reverse proxy that sits in front of a service. It could be at the Ingress layer, as we discussed earlier, connecting into Envoy so that you're seeing the traffic before it gets in. And all of those, I think, are very valid, and often it's about security in layers. Any one approach isn't necessarily enough on its own, as we can kind of see here. If you're just looking at the Ingress layer, then potentially there's still the vulnerabilities within the environment if the EastWest traffic has been compromised. So things that are doing both at the Ingress and at the application layer, whether that's through things like Istio or just sitting in front of the application, are generally going to be very valuable from ensuring that you don't end up in a compromised situation. And so what I did want to do real quick is actually just quickly jump into showing what that kind of traffic can look like from an internal perspective. So what I have here is an environment that I've set up. And this environment just timed out, it looks like. There we go. It's just a simple environment that I had set up with a couple microservices, an Ingress controller, and a reverse proxy. And kind of what we can see here is I had gone through, and this is the Ingress controller. And depending on what rules and policies that we have, we can go in and see that I had a couple of cross-site scripting attempts. I can see some other things going on in my environment. And the way I have things configured, and it's also going to be in my GitHub repository, is that anything going to this path is going to one microservice, and anything going to a different path is going to a different microservice. So we can actually see that traffic from a few different ways. So if I'm looking in here, I can see the traffic coming in from, it's actually from two different containers, but one was actually from hitting it through the Ingress controller, and one was hitting it from a reverse proxy that was sitting in front of it. And we can see the same thing from the Nginx side and then from reverse proxy. So the reverse proxy was just sitting in front of only one of the applications. So what I did here is I went through, and in this case, I have a policy set up for the reverse proxy to immediately block. Otherwise, it's going through and hitting the Nginx server sitting behind, in this case, a reverse proxy or the Ingress controller. Whereas in this case, this is behind the Ingress controller, so it's a path-based routing to the various microservice, and I don't have any policies set up to actually do an immediate blocking. Those are the main topics that I wanted to talk about, and I don't know if there's any questions you wanted to look into us answering.
Yeah, we do. We've got some great questions queued up for you here, Doug. Let's start with some questions around regarding compromised Kubernetes clusters. Can that be prevented with granularity by assigning permissions via roles? Is that a possibility?
That will have a lot of effect. Roles and namespaces will help mitigate some of the risk. But at the end of the day, once things are compromised, if you come in through the actual web application, you then have a service that's now still in a trusted environment or trusted role, as it has to have access to various APIs that are internal to Kubernetes in order to be able to access information about what it needs to do and do things. So there's still a level of risk, even if you do set up as much as you can secure roles for the actual cluster.
I mean, that's certainly something you want to do, probably along with access management, permissions to get access to those resources. But that's only part of the solution. That's why a web application firewall is so helpful, correct?
Correct. Yeah, it's as our CISO Zane Lackey likes to talk about security and layers. There's no one silver bullet that's going to solve everything. You need to make sure that the various layers that make up your application, and in today's world, that's often a microservice sitting in a container, sitting in a node, sitting in a cluster, that all of the various layers have the thought behind it from a security perspective to ensure that you're as secure as you possibly can be.
Mm-hmm. Wonderful. Next question is about the development process and any recommendations you have for how to secure images in GitHub to prevent compromised GitHub image. You were showing how you're pushing images with GitHub earlier.
Yeah, so there's a few ways. One is to definitely follow the kind of standard practices for images. So making sure you're not running as privileged unless absolutely necessary, which in most cases isn't nowadays. Running as a non-root user. So there's standards that have been released now of this is how you should secure your container. There's tools out there like the ones I briefly mentioned, Aqua, Twistlock, and there's a lot of others now that allow you to be able to do container security. So they'll actually scan your Docker files and other components to ensure that things are configured in such a way that meet those standards and are going to be as secure as possible even before you actually go out and deploy it.
Mm-hmm. Great. Talking about the development process, when you implement this into a DevOps tool chain or development tool chain, is everything automated, or are there things that each individual developer has to do to implement a web application firewall?
Yeah, so it depends on how things are implemented. So from the deployment perspective, it might be, as I was showing here with my kind of Circle CI pipeline, that actually that's not the one with the Circle CI pipeline, but it might be the code is actually separated from the overall, there we go, from the security layer as talked about. So if you're doing things at the application layer, it might be that you are going through and adding this in. So this actually just becomes part of your checks. So a simple check that I've seen customers do in the past, if they have it at the app layer, as part of this build process, is if the app has the WAF included in it, having a check to an endpoint that you'd expect to always be blocked to make sure that even before you deploy, that that's actually working correctly. When you start talking about it from sitting at a layer above it, from the Istio or Envoy perspective, it's a little bit harder to test from within your CI/CD pipeline, as that's going to be happening after it's deployed. That's where the protection kind of comes in. If your dev environment's the same, then maybe there's a particular service name that you hit to do that similar type of health check to make sure things are being protected. Otherwise, part of that is going to be ensuring that, yes, my Istio is configured, or yes, my reverse proxy, or whatever it is that's actually doing that protection is running and traffic's actually being protected as soon as that container or pod is spun up.
Mm-hmm. Wonderful. Well, let's kind of stay on this theme here. The next question is about application layer security. How far up, for folks that aren't used to working with a web application firewall, at what point does the security that it provides sort of end and the application takes over? You talked about HTTP calls and things like that that are part of the web app, of course. But what point, what kind of things that the web application firewall wouldn't do that an app developer would still want to take care of themselves?
Yep. So there's a few things there. One is the inputs, as mentioned before, with like JSON, or if you're doing it from, generally it's going to be in JSON because that's how you usually want to interact with it. But you could have it be query parameters or anything. And that's your normal development process from a security perspective. You don't want to take, as in my silly example, untrusted parameters and just execute them. That's never a good idea. Generally, you want to sanitize it, make sure that there's nothing vulnerable in there, that it actually matches a set of parameters. Another thing is around authentication. Again, what I've seen it happen more than once, is you're moving a function that was built into a monolithic application. You didn't have to worry about the roles and responsibilities. Generally, if you call that function, you're going to have the right to call that function because it's part of the overall code set and your development. So historically, if I was looking at my actual Flask server, I would have everything just be self-contained in one application, which I actually am doing here. But I could actually move out functions in here to other actual microservices if this was doing something a little bit more complex. Once I start doing that, because it's no longer trusted within the code, it's not code passing data to the child function. It's potentially something that's being externally passed via that API. There's just a lot more that you need to think about and go, oh, am I allowed to pass that? How do I determine if I'm allowed or not? What's the authentication model? Is it a token based? Is it a call out to an authentication server to verify if the way this is being accessed is correct or not? So there's a lot more complexity there around just the authentication and role-based responsibility that you have to think about when you're deploying your individual microservice.
Okay. The next question is directly related to this. It may be redundant, but you can tell for us here. For legacy apps that are being moved to the cloud, any suggestions for securing component services on the new distributed app as it's deconstructed down to be a service-based app?
Yeah, so it's definitely very related, but it's thinking intelligently about what the design is going to be before you actually start deconstructing it. It's great to have, and can I use a simple one because it's easy to understand, a function that does PDF creation, but you don't want everybody to be able to call that PDF creation. So having a common set of code or a common layer for the authentication portion is going to be important. So effectively now, anything that you deploy is going to have a function within it that either authenticates the token by calling an authentication server, submits some kind of data to another service that's going to give an approve or deny on whether it's allowed to actually run it or not. Otherwise, you run the risk of, if somebody figures out how to get to that endpoint without that authentication happening within the microservice, and they at that point can then run stuff that you don't necessarily want them to run. Everybody says, well, it's not exposed to the internet for that service, and generally it shouldn't be. You do have to actually make it exposed in order to get to it from a Kubernetes perspective. But I have seen in my past at customers services that they thought hadn't been exposed, whether somebody was testing or ran the wrong command or something like that. An internal service got exposed to the internet for a period of time. And why that happened, now your cluster's at risk, because if you were just relying on it being internal and not exposed to the internet for your security model, during that time that it's actually exposed externally, means you are now vulnerable to running things that you weren't expecting it to run.
Excellent. Next question. Still has time for a few more here if anybody wants to submit some more. Aside from locking down authentication, what are other means to secure APIs? Checking for unexpected values being passed to the API endpoint, and asking an open-ended question there.
Yeah, so it's really, I find the exact same thing, because we talk about, and you see a lot now, people talking about what's the difference between API security and web application security. In my opinion, there's not a lot of difference, because most APIs that people tend to use actually tend to be some type of web service. So it's the same things. Don't use inputs from query parameters or even JSON elements directly into things like system calls or even like SQL queries. You want to make sure that it's sanitized, that it doesn't have unexpected characters, and it is actually commands that you actually want to run before you ever actually execute things. When you start focusing on the API security perspective from a container-based world, you are focusing on a smaller surface threshold for, or a vector for attacks. And you don't necessarily have all of the same inputs and like form-based inputs that you would have historically. So it does reduce the footprint of your vulnerable vectors, but it does mean that on those ones, you still need to be just as secure as you have been with a traditional website.
Great. The next question kind of falls directly, I think, in the center of the target for you. Given that you had professional services in your title, it wasn't too hard to figure out this what you do. The question is, to be able to use your product, do you need professional services? Or is there, what would you recommend for someone who is kind of already very familiar with these kinds of architectures and security, maybe needs a light touch, versus someone who needs significantly more help? What would you say are the profile of different professional services that you would provide to those two types of development teams?
Yep. A lot of it depends on how you're deploying. So generally, from like our tool specifically, professional service of doing lots of man hours and maintenance and things like that isn't something that's required for us. And a lot of it depends on how you're deploying. So if you're deploying at the Ingress or in the service mesh model with the Envoy Istio type model, things become very simple because you can just effectively, with a couple updates to Docker files, deploy things out and you're done. Things are now actually being protected and you have visibility into that traffic like we were showing. And when you start deploying at the application layer, you can still do it all on your own, but that's generally where you can have more complexity, i.e. How do you integrate with Node.js? How do you integrate with JavaScript and Python? Because a lot of the microservices are often running a code-based web server as opposed to a traditional web server like Tomcat or Apache HTTPD or some of the other web servers out there. So generally, it's usually recommended to have somebody help walk you through it so that you know how to implement it in your code as opposed to having to stumble as you go along the way. I would say with any of the deployment models, it can definitely be done themselves.
Very good. So we have time for one more question here. Is this, you mentioned a lot about developers, development, software architectures, et cetera. Is this a tool that developers are primarily going to use, or are the security engineers, security professionals also going to seek out a product like this to take to their development teams?
Yeah, that's a great question. And I would say it's about equal in today's model. If you have the visibility, the enforcement is going to be the more important part from the security team, but the visibility is going to be just as important to the development team. Visibility allows you to be able to fix things. One of the things that when I've been talking to both the security teams, development teams at organizations in the past that I've always heard about is security just says my stuff is broken, but doesn't give me useful information. And the security team's going, I give stuff to engineering, but they don't fix stuff, so we're still vulnerable. So you kind of have this common debate about who's at fault. And a lot of that stems down to, do you have the visibility to give useful information? And also, can you provide that visibility to the developer teams so they can see the data and respond to it proactively without having to wait for the security team to instigate and be reactive to fixes? As a common example, when we're looking at things is just seeing 500s that you weren't expecting, or seeing an unusual rate of 404. It's like, oh, we deprecated that endpoint a year ago. Why do we still see all of these? How can we fix that? And now these become actionable responses that you can do, especially the things like the 500s, because they're unexpected errors. Those are things you want to solve. Are they necessarily a vulnerability? Maybe not. Maybe there isn't any impact, but it's a risk of vulnerability because it's an unexpected area or error that you can then provide, say, hey, this endpoint, here's the payload, is causing these messages. You might want to go fix that. That's now actionable responses that the engineering team can use or see for themselves what's going on and proactively fix.
Excellent, good. Well, it looks like we've used our time pretty effectively here. Thank you very much for the great presentation, Doug, and fantastic answers to our audience's questions. We appreciate those questions as well. So let's move on to our, you bet, you're very welcome. Let's move on to our gift cards that we're giving away. We have 3 $50 Amazon gift cards, and they are going to these folks: B. Miller, G. Stan, and J. Hamill. The folks here on the webinar team will reach out to you about how to get a hold of those gift cards. Just a reminder that we are recording this webinar, and we'll send out an email with the link to the recording and to the slides. That'll also be available on devops.com website. And of course, you can check out other great content there about future webinars, as well as all kinds of information about containers and security and the good stuff that we're talking about today. So please join me in thanking our wonderful speaker, Doug Coburn, who is Director of Professional Services with Signal Sciences. Great job, Doug.
Thank you very much for having me. It was my pleasure.
You bet. And we'd like to thank you, our audience, of course, for spending your time, your valuable time with us. We appreciate, we know that it's close to an hour that you've spent with us, and your time is super valuable. We appreciate that you've spent it with us. It's been my pleasure to host today's webinar. Have a great day out there, and please be careful.